PCK Science and Technologies Assessment 2A. This inquiry unit will be unpacked over the course of a term and will be driven by the essential inquiry question of how does deforestation disrupt Earth's natural systems and what actions can we take to reduce its impact? A component within this inquiry unit is the investigation, soil erosion. Can the land hold its ground? In this investigation, students will explore the current environmental issue of deforestation, examining how it contributes to soil erosion and the impacts of soil erosion on life. The soil erosion investigation is designed for Year 6 students. The highlighted experts from the Achievement Standard will be addressed with the Science Understanding Content Descriptor highlighted in yellow and the Science Inquiry Skills in green. When undertaking this investigation, students will develop the science inquiry skill of planning and conducting when they carry out the investigation, use equipment appropriately and record their findings. They will also develop the processing, modelling and analysing skill as they organise and represent their data using tables and graphs. Finally, students will develop the evaluating skill as they evaluate their observations and data to draw conclusions. Students will develop the general capabilities of critical and creative thinking as they analyse a problem, in this case being soil erosion, and examine relevant information from a range of sources about the topic. They'll also develop digital literacy as they collate their data using digital tools. The cross-curriculum priority of sustainability will also be incorporated as students learn the interconnectedness of all life forms through Earth systems and how environmental changes such as soil erosion impact all aspects of life. The aim of the investigation is to examine the impact of vegetation on soil movement, or erosion. To ensure a fair test and accurate results, the variables outlined in the table will be carefully controlled. By the end of the experiment, students will provide an answer to the question, does the quantity and type of vegetation influence the amount of soil moved when it rains? Before undertaking this investigation, I recorded my hypotheses. To complete the investigation, the list of materials will need to be acquired. When undertaking this investigation, it's important to note possible safety hazards. To minimise risk, I follow the safety precautions listed on the slide. When implementing this investigation with students, these precautions will be emphasised alongside adult supervision. Following slides list the steps I undertook to carry out the investigation. Feel free to pause the video to read the method. To record my results, I used the table to document observations and pictures. I originally planned to drain the water from the cups and weigh the remaining soil using a scale. However, the kitchen scale I used was not sensitive enough to register the soil's weight. As an alternative, I measured the soil's length on paper using a ruler to obtain a numerical value. While this method was not highly accurate, it provided a rough estimate. If conducting this investigation with students, a scientific scale capable of measuring milligrams would be necessary. I used 2 different column graphs to help interpret my results and answer the testable question. Using the pictures I took, the first graph shows the level of water turbidity in the cups in relation to the turbidity chart displayed. The second shows the amount of soil after drainage measured in centimetres. After analysing my results, I concluded that less vegetation does lead to greater soil displacement and more vegetation with strong root systems is the most effective at preventing soil erosion. In conclusion of this investigation, my initial hypotheses aligns with the results. Upon validating my results with research, it's evidently clear the power vegetation has on soil stabilisation and erosion prevention, emphasising the need to reduce deforestation acts. In relation to the unit's essential inquiry question, this experiment visually demonstrates to students how deforestation contributes to soil erosion on a smaller scale. Completing the investigation provides a foundation for deeper inquiry into the broader impacts of soil erosion on all aspects of life. For example, increased flooding, clogged and polluted waterways, the loss of soil nutrients, which reduces crop yields and food availability, ultimately threatening ecosystems and decreasing biodiversity. In the classroom, this soil erosion investigation would span over 3 to 5 days. The LAA framework would be implemented to drive the progression of the unit, equipping students with essential knowledge and skills through its 3 key phases. Day 1 would begin with the launch phase to increase the science capital in the classroom by asking questions that evoke and explore students' experiences. This could be done by reading a book and completing a TWLH chart. Day 2 to 5 would focus on the inquire phase and will begin unpacking the unit's essential question. Students would engage in critical thinking, respond to probing questions, and adopt a researcher's mindset to gather and organise information from various sources. At the end of the unit would be the ACT phase, where students apply their learning, communicate their findings, and take meaningful action to advance science and positively impact the community. Students could participate in a SOL activity where they would work collaboratively to answer the question, how can we minimise the effects of deforestation? Their findings could then be transformed into an informative poster to be displayed at school or in local shops, raising awareness about deforestation and encouraging community involvement as a form of summative assessment. Bloom's taxonomy would be integrated throughout the unit to differentiate instruction by offering tasks at different levels of cognitive demand. By designing activities that range from lower order to higher order thinking skills, you can support diverse learners while challenging all students appropriately. An example of how this could be applied within the soil erosion investigation is with varying levels of questioning, as pictured on the screen. Here are my references used to complete the assignment. Thank you for watching.